In the fourth part of synthesis to Diclofenac, we will have a look at a process which indeed works on an industrial scale and has been optimized for a continuous flow cascade. So smaller reactors, well, one after the other. Well, here we start with aniline, as you know, rather cheap, and an acylation takes place with monochlor acetyl chloride to this compound, with this boron reagent as an acylation reagent, a newly developed acylation reagent. It works with a 96% yield. Then, in a reactor stuffed with potassium carbonate, it is introduced together with this phenol. The phenol is deprotonated and will undergo a nucleophilic substitution here and substitutes the chlorine. This molecule will result, and this is not isolated. We are still in that continuous flow reactor, and in this part of the cascade we still have potassium carbonate with acetonitrile as the solvent. 125 degrees then initiates the so-called Smiles rearrangement. So the NH group is deprotonated and then it becomes nucleophilic and will undergo intramolecularly a nucleophilic aromatic substitution at this position, so that ethyl group is substituted by that nitrogen, and overall, over those two steps, here the nucleophilic substitution and the Smiles rearrangement leads us with the 83% yield to this intermediary product. So, here we have now an alcohol functionality. If we treat that with thionyl chloride and DMF, then more than 95% yield of the chloride will be formed, and with aluminum chloride we will achieve the Friedel-Crafts alkylation here. This is not isolated, it's directly treated then at elevated temperatures with sodium hydroxide, and our target molecule will result 85% yield over these two steps. So if we calculate this through, then we have a 64 overall yield, and the overall time for flowing through that cascade is 205 minutes. Well, I think this is a really impressive result. Thanks for listening.